Section 9.4, Systems of Quadratic Equations. We're also going to look at how to identify conic sections. So the first thing is just looking at the general form of the four different conics we have learned and being able to identify them. So if you look at the first one, x squared plus bx plus cy plus d, our focus is really on the squared terms. That almost in itself will help us identify each of these. So on the first two, you notice that there are only one squared term, and the only conic that has one squared term is the parabola. So the first two are parabolas, and once again because there's one squared term. On the next equation, you have 1x squared plus 1y squared. So there's two squared terms and they're being added, but then you also notice that the coefficients are the same. That represents a circle. So the sum of two squared terms with same coefficient. On the next one, we still have the sum of two squared terms, but if you notice, the coefficients of those two squared terms are different. So that represents an ellipse. And once again, we are still adding. So once again, sum of two squared terms with different coefficients. And then the last two, you have the difference of two squared terms. And so that represents the hyperbola. And so a hyperbola is the difference of two squared terms. Now in each of these the coefficients appear to be different, but the coefficients can be the same. It's only the difference of the two squared terms that you absolutely need. So that's how you identify the four different conic sections. So if that wasn't enough, here's a quick kind of flow chart that you can use to help you identify how many squared terms, how many variables are squared. So we talked about that first. If there's one, then it is a parabola. If there are two, then it's one of the other three. And then rewrite the equation so both variables are on the same side. That way we know it's a sum or a difference. Next, are both squared terms positive? If the answer to that is no, which means you are subtracting, then it is a hyperbola. And then the third question, are the coefficients of the squared terms the same? If the coefficients are the same on the two squared terms, if you're adding, then that means it is a circle. If they are not the same, then it's an ellipse. And so that's another way that can kind of help you identify or answer that question as to which conic section it is that you're looking at. So here's an example. Classify the graph of each equation and explain. So go ahead and pause the video, do these 8 questions, identify them, explain them, so you're able to understand which conic section it is without having to go through the whole process. So here are the answers to the 8. The first one is a hyperbola because you are subtracting the two squared terms. B is an ellipse because you are adding the two squared terms and their coefficients are different. C is a parabola, you got one squared term. D is a hyperbola, you are subtracting the two squared terms. E is a circle because you're adding the two squared terms and their coefficients to the same. Same thing for F, you're adding the two squared terms and their coefficients are the same. G is an ellipse because you're adding the two squared terms and the coefficients are different. And H is a parabola because you have one squared term. The second part of this is being able to solve systems by graphing, substitution, or elimination. Example 2, I'm going to start by showing you by graphing just to kind of help you remember in terms of solving systems. We're looking for the intersection of the two. So right now on the first part, we have an ellipse because we have two squared terms that are being added and the coefficients are different. So we're going to need to set this one up. We don't have to complete the square or anything. We can just divide both sides by 36. So that'll give us x squared divided by 36 plus y squared divided by 9 is equal to 1. That leaves us with a center at 0, 0. It will be horizontal because the a squared, which is underneath your x squared, is 36. It's the largest number. So we know that the major vertice will be at negative 6, 0, and 6, 0 because it's horizontal. The minor vertice will change your y value. by 3, so negative 3, 0, and 3, 0. And because I'm just looking to solve the system, I don't need to find really anything else. I just want to make sure that I can graph it. So we'll go to positive 6, 0, negative 6, 0, and then 0, negative 3, and 0, positive 3. And then we'll go ahead and graph that the best we can here. Alright, now let's go ahead and graph the next one. Now the next one is a parabola. There's only one squared term. We want to solve for the term that is not squared, which is the y, so all we need to do is subtract 3, which leaves us with the vertex at 0, negative 3. This is a vertical parabola which opens up because a is 1. So let's see, 0, negative 3, we can see that actually that will be one of our solutions because both graphs share that in common. And then the next part is, finding the focus and graphing that. We need more points than that, so we're actually going to go ahead and just use a t-chart. Plug in values for x. We already have 0. I'm going to do 1, but I'm going to do plus or minus 1 because once I square it, it's not going to matter. So whether it's positive 1 or negative 1 squared, it's going to be 1. 1 minus 3 is negative 2. And then the same thing with 2, plus or minus. So 4. 4 minus 3 is 1. And I'll do 1 more plus or minus 3 would be 9 minus 3 is 6. So that should give me enough points to see what I'm looking at here. So at negative 1, we're at negative 2. Positive 1, we're at negative 2. At negative 2, we are at 1. And at positive 2, we are at 1. And then negative 3 at 6. And positive 3, we're at 6. So if we graph the parabola here, we can see one of the solutions is going to be at 0, negative 3. That ordered pair satisfies both equations. What we're not sure about is where they intersect here and here. So the graphing isn't going to be able to help us for that part, but we're able to see that there are going to be 3 solutions. So we're going to take this a little bit further, and we're going to go ahead and solve this using one of the other algebraic methods, substitution or elimination. So let's look at our 2 equations. X squared plus 4y squared is equal to 36, and x squared is equal to y plus 3. So x squared is equal to y plus 3, so we can substitute y plus 3 in for x squared, and that'll give us y plus 3 plus 4y squared is equal to 36. It is a quadratic, so let's go ahead and set it up in terms of everything equaling 0. So 4y squared plus y, subtract the 36, that'll give you minus 33. Maybe not the best one to try to factor, but it does work. So if you don't see this, then you can use probably the quadratic formula. So we'll get 4y minus 11, and then y plus 3, and you can double check that. You will get plus y as your middle term. So we'll set these equal to 0. And then that will give us 2 of our solutions. So y is equal to 11 fourths, and y is equal to negative 3. So now we have to substitute in to find the x value. So we'll start with y equals negative 3. Plug that back into one of your 2 equations. I'll go ahead and plug it back into the parabola. X squared is equal to negative 3 plus 3. So x squared is equal to 0. So when you take the square root, you just get one answer. So that's when 0 and negative 3, that was the one that we found earlier on the bottom of the ellipse in the parabola there. And then now we also have y equals 11 fourths. So I'll do the same thing, plug that into the parabola equation. X squared is equal to 11 fourths plus 3. And so that's x squared is equal to, find a common denominator. It'd be 4, so 12. So it looks like 23 over 4. Take the square root of both sides. Don't forget, you get positive or negative the square root of 23 over 2. So that leaves us with our last two solutions, the square root of 23 over 2 comma 11/4, and then the positive one, positive square root of 23 over 2 comma 11/4. And so those are our three solutions to the quadratic system. Alright, the next two are just examples. I'm not going to graph the next two, I'm just going to solve these algebraically, which is what we'll probably do in most cases anyways. I noticed that the y squared, and for both of them, one's positive, one's negative. So I'm going to go ahead and use elimination. So I'm going to line these up. 9x squared minus y squared is equal to, I'm going to subtract the 16 so I make sure everything's lined up here. And then we'll get 14x squared is equal to 14. So I can divide by 14, then go ahead and take the square root, and I get plus or minus 1. So I got to use both those values. If I say x equals negative 1, I'm going to go ahead and plug that back into the ellipse equation, which is the first one. So 5 times negative 1 squared plus y squared is equal to 30. And really, it won't matter if it's negative 1 or positive 1. You're still going to get 5 plus y squared is equal to 30. So y squared is equal to, that's a 30 there. Y squared is equal to 25. So y is equal to plus or minus 5. And the same thing is going to happen when you plug in 1. You're going to get y is equal to plus or minus 5, because when you square 1, you get 1 times 5, which is 5 again. So that'll leave us with 4 solutions. I want you to write all of them out. So negative 1 can give you the solution of negative 5. If you plug in negative 1, you get the solution of 5. If you plug in 1, you get negative 5, and you plug in 1, you can get positive 5. So those are 4 different answers to that system. Alright, if you want to go ahead and pause the video and try the last one on your own, you can do so. We're looking at a circle on the first one and a hyperbola on the second one. Once again, it looks like if we line these up, we have our y squareds that will cancel. So we'll do x squared minus y squared. Now on this one, I'm going to subtract 9. So minus 16x, then we have this minus 9. I'm going to just try to line everything up so I can make sure I add it correctly. So x squared plus x squared is 2x squared. The y squareds cancel. Don't forget your minus 16x, and then plus 30. So if we divide that by 2, we'll get x squared minus 8x plus 15. We can factor that to x minus 5 and x minus 3. So we have 2 possibilities of x. X is equal to 5 and x is equal to 3. So we'll plug both of those in. X is equal to 3. I'll plug that one into the hyperbola. So this will give us 3 squared minus y squared is equal to 9. That'll end up being 0 is equal to y squared. So y is equal to 0. So one of our solutions is 3 comma 0. Then we'll plug in x equals 5. So that's 5 squared minus y squared equals 9. That'll end up being 25 minus 9 is 16 equals y squared. So y would be equal to plus or minus 4. So that'll give us an answer of 5 comma negative 4 and 5 comma positive 4. So our 3 solutions on this one are 3, 0, 5, negative 4, and 5, 4. And that is it for systems of quadratic equations. Last thing is write a summary for this section. What are those important pieces that we need to pull from this